So a better method to estimate the test error when we do not have a lot of data available is called leaveoneout cross-validation. And here is the idea. So we have our data set, right? So this is like we have a lot of observations, 1, 2, 3, 4. So then we are going to do it like this. So we're going to remove one of these, and we are going to use the rest of them to train our model, right? So if this, let's say, polynomial of degree 5, then we are going to fit a polynomial of degree 5 using the rest of them. So which is why it is called leave one out. So we just leave one observation out. Okay, so these are used to train our model f hat. And then we are going to report to find the error of our model f hat on this observation that we left, right? So if this is our observation, say I, that we left, so then we are going to find our f hat of xi minus yi squared. So this is going to be our squared error. And we have to repeat it n times. So sorry, n capital times. If the number of observations is n capital, then we have to repeat it n capital times. So the leave one error estimate for the test error is going to be just the average of these errors of every individual model. So every individual model, it has seen almost all the data available except for just one observation, right? So we are going to apply this model to the only one observation that it hasn't seen, and we are going to find the average of this error. So notice that this y hat is actually, we took our model f hat. So I probably should denote it as say minus I. So meaning that we trained it on the data where the ith observation has been removed, and applied it to xi. So this is our y hat I. So this y hat I, they are obtained by running different models for every I. So every I has its own model. So here is how it works in practice. And so if this is, say, they're very simple, just 7 observations. So here the number of observations is 7. If we do it, so I did it. I did it myself in R, right? So and this is what I got. So the first row here is a model trained on this data set with the first observation removed, right? So to produce the first row here, I removed the first observation, trained the model on the remaining 6. And this was a quadratic polynomial in horsepower. So x is horsepower and y is miles per gallon. Right, so then I trained another model, right? So what I did, I removed the second observation, so used this together with this to train the second model. And these are the coefficients that I obtained. But then when I computed the error, so I applied this model to the observation that was removed. And then this is how I found this error, and so on. Right? So I had to run it 7 times. And after this, what I did here, I tried polynomials of different degrees. So from 1 to 10. Right? So basically, so first I feed the polynomial of b0 plus b1x. Yeah, I did it on the whole auto data set. So which means that I fitted 392 polynomials, linear polynomials, right? So then I fitted 392 quadratic polynomials. So b0 plus b1x plus b2x squared. So then I fitted 392 polynomials of degree 3, 4, and so on up to 10. And then, so every time I found the error, and then I just reported this error. And apparently for this data set, so what we see is that the best, the value of degree that minimizes the leave one out cross-validation error is 7. Okay, so this was leave one out cross-validation. So please do this little quiz.